initial release of StowMan S, we consider a service going between two regions. We are going to stow the vessel just after the turn port in the first region. At this point we have a load list for the port, but we don't have a forecast for the remaining ports. Our objective is to stow the vessel such that it has the highest possible utilization on the front haul. The optimizer can be given different criteria for what to optimize on the front haul. We can have excess capacity on the front haul, in which case we will focus on optimizing crane split, or we might be pressed for weight or volume. So let's assume that we are pressed for volume. Secondary objective is to have a good crane split. So here we set a minimum crane intensity for each of the data ports, corresponding here to how many cranes that are available in ports. We then can set some stability targets for the stow in the current port. So here I give it a minimum GM of 1 meter and a maximum GM of 5 meters. I set the trim to be between -1 and 1 meter, because in this port I don't care that much about the trim, but I don't want it to be extreme either. For the tanks, we currently do have some water in the tanks, and if the optimizer is to fill some more water, I want to avoid that it does it in the side tanks. So I'm adding now a blocking rule saying keep the side tanks empty, but otherwise I allow it to both load and discharge ballast water in the tanks. One way to guide the optimizer is to stow some of the containers. So I could stow containers for the second port here in bay 18, and now the optimizer has to find a solution where this is fulfilled. So let's start it. Up here we can control the optimizer, and it's always telling what's going on in this area here. There's also a console from the optimizer where we can see messages printed from the optimizer. Right now it's planning the crane utilization, and now it's distributing weight, and then it ends by actually stowing the containers into individual slots. And when it's finished, we can see a little ready sign here. And then we can open a dashboard which shows the pool of solutions currently made. So what we see here is the layout of the current port of the plan that was just computed, the moves of the crane in the port, and we also see now in this port we achieved a CI of 6.4, and we only need 3 because we have 3 cranes in this port. Over here we have some more KPIs of the plan, but let's use it by loading it into StowMan. And now we see a solution that truly did stow containers in this area in port 2. And regarding the volume optimization, we can go to this bay here, and you can see we have a mixture of DCs and HCs. The HCs are the one with this triangle that gives us the maximum volume utilization of these out of region containers, and this is what we want. Other approaches in the stow is to use so-called paired block stowage, where we say we stow the same POD in wings and center, and we also try to minimize the torsion in each bay, so there's very little torsion in this vessel. Regarding the tanks, we were able actually to reach a trim quite much in the region of 1.1 meter without using any ballast water, so we used the containers to achieve that trim. But I might not be completely happy with this. What was made here might be okay, so let's just keep that. We lock this off. But then here I have some heavy containers, and I might actually want to restrict the optimizer from not stowing any heavy containers in this area. So I get this rule editor. I don't want to have any heavy containers, so from 17 to 36 tons. Add this rule. And actually I also don't want to have any containers in this whole bay here, because I'm going to have some break bulk. But there are other parts of the stow that I'm fairly happy with, so let's just lock that as well. Meaning now that the optimizer is not allowed to change it. And then we can remove all the cargo that I have not locked and make a restowage. So we run the optimizer again. It's now assigning cranes, then doing weight optimization, and after that it will stow the individual containers. Now it's ready, and we have now 2 solutions in the solution pool. As you can see, these are quite different solutions. Let's take a look. As you can see, we have a solution now where there are no containers in the last bay, and if we take a look at this bay, we now don't have any heavy containers on deck as required, and we still are stowing for port 2 in bay 18. So with this I'll end this short demonstration of the alpha release. We hope that you will do a trial with us to check it for yourself. Thank you very much.